All righty. All right. So let's take a look at the force diagram. Force is applied at an angle at a 50 degree below horizontal. Now, not the best way to push a book, but a force is applied at an angle of 50 degrees below horizontal to push a 50 below horizontal 1.5 kilogram book across the desk at a constant speed. So acceleration is equal to 0. F net is equal to 0. So how do we draw this force? So the applied force would be like this. Okay, that's the applied force. And then we have our weight, we have our normal force, and of course we have our friction, and there should be kinetic friction. It says find the applied force on the book, and we will go ahead and draw the free body diagram with all of the forces broken down. Well, actually, the normal force is the only upward force on this diagram, but we have two downward forces. Okay, so we have the F applied sine 50 degrees, and then we have F cosine 50 degrees. And we also have FK. All right. So, so these are the things that we have. All right, now we've got the mu. The mu is 0.3. So if we have the normal force, then we can figure out the friction, or the maximum friction. Okay, so but before we do anything, I hope you all can have this correct free body diagram. Okay, so so usually you have a force. I mean, typically you do you pull, you push or pull something. Well, I mean, if you push it, I think that makes sense. You push it down, and but then it's going to increase the friction in that case. All right, how do we find out the force of interest? Well, let's write down something that we know for sure. We know that all the forces in the y direction must equal to 0. We know that all the x direction forces must add up to 0. Is it helpful? I don't know. Well, let's just go ahead and write it now first. Okay. Maybe it's going to be useful at some point. Okay. So that means F K, the kinetic friction, should equal to F cosine 50 degrees. Again, we don't know what the F applied force is. We will go ahead and find it out in just a moment. Okay, and then, I'm sorry, my bad. That's not right. That's the x direction. Sorry, the y direction should be the normal force minus mg minus f sine 50. It's equal to 0. Sorry. Okay. Do we have the mass? We have the mass. Now, so the way I'm going to handle this calculation is this. Let's go ahead and see if there's anything we can substitute. Because we want to have an equation with the only variable, f. So I want to see if there's any way possible so that I can replace all the things to an equation so that it will, the only thing that's left is the letter F. That's the only unknown. And I think we could do it. Because normal force could be expressed as F cosine 50 degrees divided by mu. And that means I can replace this normal force on the left with this expression. and F is the only unknown. We know the mass of the book, that's 1.5 kilograms. We know the gravity, that's 9.8. So the only unknown left is our letter F. So let's go ahead, substitute in here. Mu, it's what, 0.30? And then minus F sine 50. And let me throw that mg to the other side because it doesn't have an F in it. So now we're just using numbers to communicate. Cosine 50 degrees divided by 0.3, sorry, hold on. Cosine 50 degrees, close parentheses, divided by 0.3, it's going to be 2.14 F. Sine 50, it's 0.766 F. And then 1.5 times 9.8, it's 14.7. That will be newtons. So 2.14 minus 0.766, that'll be 1.374 F. It's equal to 14.7 newtons. So if you divide 14.7 by 1.374, then the applied force would be 10.7 newtons. Okay. So this is as difficult as it can get in terms of all the quantitative analysis regarding to all these friction forces. It's all about your basic algebra skills, that if you have multiple unknowns, then chances are you are going to substitute. And can you substitute to the point that you will have only one single unknown at the very last? Okay. So as you can see right here, I wrote these two statements or equations at the very beginning. Are they useful? I hope. Can I see the very direct relationship? I will be very honest that as a student, I probably can't. And that's the philosophy that I've been preaching for the past few weeks. And that is, if you could write down something, go ahead, write it down. It won't hurt you. If it's not useful, just leave it there. But chances are, they are useful. So seize every single opportunity to write something down, and that will be a good resource for you to handle your calculations. Okay?